In this video, we're going to be talking about radians and degrees. Now, I thought I'd give you guys a heads up, but in this video, we're using a lot of fractions here. So I want you to kind of switch your brain into like fraction mode where you're finding common denominators because we're going to be handling circles. And with circles, we're going to learn how to divvy up or divide up the circles, and thus we need fractions to do that. But let's get into the warm-up problem here. So the warm-up is asking you to draw a circle. Now I've already drawn a circle for myself, and basically it is on a coordinate system, as you can see here. And they're saying that the radius of this circle is 1 unit. So this is what we call a unit circle because the radius here is 1 unit for both of these circles. And it specifically asks us to label the degrees and radians for the circles. So this one, we're going to do it in degrees. And how I want to start off with is to understand that this circle is if we were to go around the circle, we create a revolution. So one revolution is, in this case, 360. So if you've already learned about like circles before, you know that circles, if you go all around the circle, you have 360 degrees, which is also called one revolution. So it's one cycle around the circle, but usually when you're sitting on this side of the x-axis, this is your starting place. And so when you're starting this, the angle here is 0. So when you're right here on the x-axis, on the right side of the x-axis, you're starting at 0 degrees. And then when you get to here, notice that you've went from 0 to this y-axis. So you just went from the x-axis to the y-axis, and that is 90 degrees, which should make sense because if you really look at the coordinate system, this here is 90 degrees of the coordinate system. So that's why when you reach to this top, it's 90 degrees. And so if this is 90 degrees, that means when I jump to here, you guys can probably guessed it, 90 plus another 90 makes 180. So now we're here on the other side of the x-axis. Well, if this here is 180, if I add another 90 degrees to get to here, 90 plus 180 is 270 degrees. And then if I add another 90 degrees, I'm back to 0, or in this case, I've completed the 360. So what I want you guys to start putting together is that each part of the coordinate or quadrant here, so let's call this quadrant 1 is 90 degrees. So if I go to the next quadrant, that's another 90 degrees. And then the next 90 degrees, and then the next another 90 degrees. So I want you to start thinking of these as like boxes or quadrants. And every time you move to a different quadrant, that's about 90 degrees to each quadrant. So when you look at the whole circle here, it's 360 degrees. But at the starting, you start at 0, then 90, 180, 270, and then 360. You are going by multiples of 90s. Now we can get really sneaky here and talk about like angles between 0 and 90. Like this here would be half of 90 would be 45 degrees. So this here could represent 45 degrees. And we can get into more details, but let's not do that yet. I just want us to look at this circle as in degree mode. Let's talk about radians next. Now, in your geometry class, you might have heard of the word radians, but I'm going to assume you don't know anything about the word radians. And to help you understand, I want us to understand the circumference formula. When you're looking at the circumference formula, you might remember that it's 2 pi r. Now, I've already told you that this here, the radius, is 1. So if I plug in my radius, which is 1, I can get my circumference. Well, 2 times 1 is just 2, so this is just 2 pi. So my circumference here, or the distance around the circle, is 2 pi. So if I think about this in radians, I would start out 0 again here, And if I go all the way around in one revolution, I complete a distance of 2 pi. So radians is also another way we can describe angle, or in this case, the distance of the circle. So when we're talking about radians, I want us to start thinking about fractions and splitting up. You know the entire circle is 2 pi, okay? That's what we know. So in this case here, what we need to backtrack is, what if I just want half of this circle? If I just want half of this circle, which is right here, what is half of 2 pi? Well, if I just take 2 pi and divide it, that's just 1 pi. Essentially, I just took the 2 pi divided by 2. That is going to cancel, leaving me with just 1 pi. Think of this as being a 1 coefficient in front. But yeah, just 1 pi here. So that means from this x-axis to the other side, this is about an angle of pi. Let's split that up even more. If this line here is a pi, then what is half of it? What is this point right here in radius? Well, if I think about it, if this whole thing is a pi, if I half this guy, wouldn't it just be pi half? Like pi over 2? Right? All I did was just take the pi and divide it by 2, kept it as a fraction. I'm not going to play any more than that. I'm just going to call it pi over 2. So from here, we start at 0, like we would do here. And then if we went to the y-axis, this here was 90 degrees. Well, it turns out in radians, we represent that as pi over 2. And then if I were to go to the next axis, which in this case is right here on the left side of the x-axis, well, that's pi. Whereas in degree mode, it is 180. So 180 and pi are equivalent. This is how we write it in radians, but pi represents actually 180 on the coordinate system. Kind of cool when you start thinking about things, but let's complete the circle here. So if this is pi, then what is this part right here? Well, we know, if we really think about this, from 0 to this portion here is half of pi, right? Or pi over 2. So if I think about this here, if I were to add another half a pi or pi over 2, I can get this point from pi. So if I think of this as 1 pi, I can also think of that as 2 over 2, right? This is also equivalent to being 2 over 2. So if I add one more pi to it, that's 3 over 2. So essentially what I did was I looked at this pi here, and I made it into a fraction by making it 2 over 2, because 2 over 2 is just 1. It's redundant. But what I'm doing is taking this fraction and adding 1 pi to it so I can figure out what is this part of the circle. So let me show that in a different way, if that didn't make any sense to you. So essentially what I did was I took the pi, and I added it with pi over 2. Because I know that this portion is pi over 2. So if I were to add pi with pi over 2, that's a fraction. And so I have to put this over 1 to add, because I can put any number over 1. And then I'm going to multiply the top and bottom by 2 to make a common denominator. And so if I add the top together, that's really just 1 pi added with 2 pi. So that gives me 3 pi, and then the denominator just swings on over, so it's just a 2 in the denominator. So that's how I got the 3 pi. Is essentially, I'm adding pi with half a pi to get here, because this is a half a pi. Now, if I were to add another half a pi, I would get to 2 pi. Because if I add another 1 pi to 3 pi, that's 4 pi over 2, which is also just a 2 pi. 4 divided by 2 is just 2. That's why this here is a 2 pi. And there we go. That is the complete revolution. So what I want you to grab from here is that in radians, we can represent a circle from 0 to pi over 2 to pi to 3 pi over 2, and then all the way back to one full revolution, which is 2 pi. A whole complete circle is 2 pi. The distance around this entire circle is 2 pi. Okay, that was a lot to sink in. So maybe take a moment to digest what I did and then come back. But I am going to head towards standard position to talk about more about how it is represented on a coordinate system. Let me erase this guy here. So before we can start graphing degrees and radians on a coordinate plane, let me just first explain that when you have a positive angle, you always draw it counterclockwise, which is like moving the opposite of a clock direction. So this way. Whereas if we're talking about negative angles, you go clockwise, which is the direction of a clock. Another thing I want to explain here is that typically when you draw an angle on a graph, you want to show your initial angle. Where does the angle start? And it usually starts at the 0 mark, or the 0 degree or 0 radians mark. And then if you're heading this way, right? If you were heading this way, this would be a positive angle because you're heading in the counterclockwise direction. And then the end angle is what we call the terminal angle. Wherever the angle lands is the terminal angle. So this terminal angle is in the second quadrant because you might remember in your other math classes that we always call the positive y and x the quadrant 1. This is quadrant 2. Down here is quadrant 3. And this one's quadrant 4. So what we're going to be asked to do is to sketch the angle in a standard position, which is drawing it on a coordinate system, and then determine the quadrant that it's in. So we're now in this chapter where we're going to be talking about trigonometry. We're getting close there, but we need to talk about switching from degrees to radians. So let's get started with just sketching angles first. So the first 4 problems are in degree mode. So if I just draw myself a coordinate system, remember we start at 0, then this is 90 degrees. Now, if this is 150 that I have to draw, I know that my my initial angle is going to sit right here, right? I get to start at 0, but then I need to draw the terminal angle somewhere. So from here, 0 to 90, that's not enough. I need to get to 150. So the next axis here would be at 180. And that's too much. I don't want to go past 180. So I know I'm somewhere between 90 and 180, so I'm going to draw my angle between there. And I don't have to be perfect about this. I'm not going to try to grab out a protractor and try to measure that there is 150, but I want to make sure I'm in that quadrant. So essentially what I did was I'm going from the initial angle to the terminal side, which is here. And so this represents my 150, and I'm in the second quadrant. So that is my quadrant number there. And that's it. So all you're going to do is sketch the graph and tell me what quadrant it's in. Let's try out this one here. So again, I'm going to draw my coordinate system. Got to start at 0 for my initial side, and now I have to draw my terminal angle and see where it lands. So again, this here is 90 degrees, this is 180, and so that's too little. 180 is too little because I have 206. So it's past 180, and here is 270. Remember, just add 90 degrees. And that 270 is too much. So I know it's between 180 and 270, so that tells me it's in the third quadrant? Yeah, that's the third quadrant. So from this initial side to the terminal side, that can be represented as 206 degrees. And that's it. Oops, I didn't mean to do that in red. Let's do that in green. All right, so this next one here is negative 60. So we have a negative angle now. Let's see how we would do that. So these here, I was going counterclockwise, so this direction. Whereas if I have a negative angle, I have to go clockwise. So let's see how we would do that, because we still have to start at 0. So this is 0 degrees here. But if I'm going clockwise, because this is a negative sign, so let me just point out this is a negative sign, so I have to go clockwise. So that means I have to go this direction. Let me just first draw my initial side. So here's my initial side, and I have to go this way. Well, I only have to go 60 degrees. So if I were to go here, this line right here, instead of it being 270, because I went clockwise, this is actually negative 90 degrees instead of 270. Does that kind of make sense? Because I'm going in this direction, which is 90 degrees worth, right? But because I'm going the clockwise, this is going to be a negative 90. So I don't want to pass negative 90 because this says negative 60. So I am going to stop between 90 and 0, so maybe somewhere here. Just draw our terminal side. So I'll stop right there and call this negative 60 degrees. And so notice I went clockwise when I did that, and I didn't go this way, or else that would have been wrong because that's the positive direction. And so I'm actually in the 4th quadrant when I do that. And there we go. All right, let's check out 405 and how we would work that out. So for 405, if we were to sketch the graph here, 0, 90 degrees, 180, 270, 360, but that's not enough. This is 405. So if I were to do another 90 degrees after 360, 90 plus 360 is 450. If I add 90 to 360, I get 450 if I were to come back to this side. So it's like my initial angle's here, right? And so I circled all the way around to 360, but that wasn't enough. And so I had to go a little bit more to get to 405 degrees. So I don't want to pass 450 degrees, or else that would be too much than what I actually have. So on this y-axis, this would be 450, which is too much. So I want to be between somewhere in the 1st quadrant. So this is the 1st quadrant. So there are times where you can pass the 360 is what I'm trying to point out. All right, so let's take a look at radians and how we would work out those problems. So for radians, let's kind of switch our gears to thinking like fractions. So this starts at 0, and then this here, if you remember, this is pi over 2. This is half a pi because over here is pi. So that means this here is half a pi, so pi over 2. So if I think about, pi over 6 for a moment and compare it to pi over 2, I can change this pi over 2 to a denominator of 6 if I multiply the top and bottom by 3. So this actually is equivalent to 3 pi over 6. Now what I'm doing here is getting a common denominator because I want to compare and see where this pi over 6 is on the coordinate system. So that's why I'm changing this pi over 2 to 3 pi over 6. So these two are still equal to each other, but what I notice is that this is 1 pi over 6. So it's not bigger than 3 pi over 6. So that means I can't pass this quadrant. So my initial angle starts at 0, but I'm somewhere in the 1st quadrant to represent 1 pi over 6. So this is in the 1st quadrant. And there we go. So what you'll do is look at the radians, but you might need to change them to a fraction that has the same common denominator. It makes it a little bit easier to figure out where it's located. All right, so again, I'm going to try this out. This starts at 0. And then from here, this is pi over 2 and pi. So let's just take a look at what we have. We have 3 pi over 4, which if I think about it, 3 over 4 is more than a half, right? So in this case, we need to be looking maybe in this quadrant perhaps. So if I think about pi, pi is just 1 pi, but I can manipulate this into a fraction. So if this is just pi, I can also say that this is 4 pi over 4, right? Because 4 pi over 4 is still 1 pi. Like, think about it. 4 divided by 4 is 1. This is still a 1 pi. What I'm doing here is creating common denominators to make sure that 3 pi over 4 is between this quadrant. And it is. So 4 pi is way too much than 3 pi. So I have to make sure that this angle, 3 pi over 4, is between pi over 2 and 4 pi over 4, which it is. So my initial angle started at 0 and it swinged to this way to 3 pi over 4, which is in the second quadrant. So this is in the second quadrant. All right, let's try out 11 pi over 6. So if I look at 11 pi over 6, 11 over 6 is already more than a pi. Like, think about it. This here, pi is 1 pi, or 6 pi over 6. All right, 6 over 6 is just 1. So I have 11 of those 6's. So if I go to the next one here and add another half pi, that would end up being 9 pi over 6, because a half a pi is 3 pi over 6. So if I add 3 pi to 6 pi, I get 9 pi. And that's too little as well. So if I add another 3 pi, I get 12 pi over 6. And 12 pi over 6 is actually 2 pi, right? 12 divided by 6 is 2 pi, which is correct because in this case, 1 full revolution is 2 pi. So if I look at this, 11 pi over 6 falls between 9 pi and 12 pi. So this here started initially at 0 and then landed here because it swinged all the way around until it landed in the fourth quadrant for 11 pi over 6. And there we go. All right, so that's the end of this video. I know it was kind of long, but this one is probably one of the most important skills to learn before we can begin the next concept.